All right, in this video, I will be talking through page 17 in the notes packet. Here we're learning about intercepts. So hopefully you've seen this topic somewhere along the way before. I know we've mentioned it in passing in class, but there's two different types of intercepts. I'm actually going to start on the right side here. I'm talking about y-intercepts. So y-intercepts, that's where the function crosses the x-axis. So I wish I had put a visual here. You think about something like this, and we have our function that looks something like that. Our y-intercept is where the function crosses the y-axis. These are generally pretty easy to find because they occur when x is 0, and because our function is often written as like a function of x. All we need to do to find y-intercept is just plug in 0 at the function. So for example, if we wanted to find the y-intercept of this function down here, g of x is equal to 34x to the 5th plus 5x to the 4th minus x cubed is 15x plus 2. It looks complicated, but really we know that the y-intercept is going to be at g of 0, which means it's going to be 34 times 0 to the 5th plus 5 times 0 to the 4th minus 0 cubed plus 15 times 0 plus 2. In every term here has a 0 being multiplied. So all of those are going to cancel out, and we're just going to be left with g of 0 is equal to 2, meaning that our y-intercept is going to be at the point 0, 2, right? Your y-intercept, we're talking about points, so we want to write it as a coordinate pair, but it occurs when x is 0 and whatever the value of y is associated with that x value, so in this case 2. So y-intercepts, those are generally the easy ones to find. X-intercepts can be more complicated. So the x-intercept, that's where the function crosses the x-axis. So in our little drawing up here, right, we have the x-axis, we have our function. Where those two cross, that's your x-intercept. And here, because it is a function of x, and we know that multiple x values can take on the same value, right? It's just we can't have multiple y values for a single x value, but we can have multiple x values that go to the same y value. That's not an issue. So that means we can have multiple x-intercepts, right? If it's a function, you'll only have one y-intercept because when x is 0, there's only one value. But for x-intercepts, you could have infinite x-intercepts, and there actually are many functions where that is the case. But let's start with a simpler case. So for example, if we had a linear function, f of x is equal to 3x minus 21, well, our x-intercepts occur when y is equal to 0. So it's when y is equal to 0 or when f of x is equal to 0, right? When the output of the function is 0, that's where our y-intercepts occur. So how we can do that is we can take that's where our x-intercepts occur. So how we can find those is we can take our function, and we know that f of x is going to be equal to 0. So it means 0 is going to be 3x minus 21. And if we solve this backwards for x, we'll get the x value for which f of x is 0. And we know that that's our x-intercept. So we'll do that by adding 21 to both sides. We get 21 is equal to 3x. Divide both sides by 3. And we get x is equal to 7, meaning our x-intercept is going to be at 7, 0. Right, your x value as a coordinate, then your y value. So that's our x-intercept for that function. However, these can get more complicated to find, right? If you have more complicated functions, we can't just set y equal to 0 and solve it in a straightforward manner, right? Like imagine thinking about when is this function equal to 0, right? It's not very straightforward. So to do this is where we're going to use our graphing calculator, right? We're going to start using technology to find these y-intercepts. So for our example function, we're going to take this function h of x is equal to x to the 4th minus 16x minus 32. And we want to try and find the x values, right? The x-intercepts for it. And so how we're going to do that is we're going to go to our calculator. You want to hit this button in the top left that says y equals. And then in y1, you want to type in the function that we have. So for y1, we want to type in x to the 4th minus 16x minus 32. So the x button, that's the second one down there. X to the 4th minus, right, it's minus, yep, minus 16x minus 32. And now if we hit graph, we're going to see the graph of our function. You're not going to need to do it for today, I don't think. But if you ever want to change the window, right, change how much of your function you're seeing, you can go here. The xmin and xmax, that shows you how far left you can see and how far right you can see. We'll leave that the same way. We'll leave that like that. But the y max and y min let you figure out how far up and down you can see. So for example, if I go to the graph, I can see that I can't see the bottom of my function. So I might want to go to window and I might want to change my y min. Maybe I'll change it from -10 to -40. Maybe I'll change it a little bit more. Maybe we'll go to -50. Maybe we'll go to -60. All right, now I can see my whole function. I can also see that we're going to have two x-intercepts, right? Because the little line up there, that's our x-axis, and we see that we cross it twice. How are we actually going to figure that out? Well, for this, we want to put 0 in y2. The reason for this is we're essentially graphing two different functions. We're graphing the one that we care about, and then we're graphing the function y equals 0. As you can see, it now shows up in the graph there, y equals 0. And then we want to go second trace, and we're looking for the intersection. We're looking at where does the function that we care about equal 0. And we want to scroll over, find the intersection that we care about, hit enter. We have to hit enter 3 times. The first one says use the first function. The second one says use the second function. The third one is something called guess. What that means is it's making sure that we're looking at the right intercept. So that's why you need to go over to the one that you care about. When you hit enter the third time, it'll pop up. We can see that leftmost intersection is x equals -1.59 and y equals 0. And now if we want to find the other one, right, because we know that there's two different values where this function equals 0, where it intersects the function y equals 0. Well, now we just go to intersect again, but now we want to use our arrows to go all the way over close to this intersection, and then we hit enter 3 times again. And we can see that this one is at 2.989, 0. So that's how you use technology to find your two intersections. And you will need to do this as many times as you need to get all of the intersections of the function.